Before we get started, please make sure that you have printed the PowerPoint for section 6.2 so you can make notes as we proceed through this section. So as we work through our logarithms, we're going to use the information about the ability to convert from exponents to logarithms and logarithms to exponents, and it's a little clearer on your paper, but we have our base to the exponent equals the result, and that allows us to take our logarithm in the base that equals our exponent, so that's b to exponent a equals c. So the logarithm in base b of c equals a is equivalent to the exponent b to the a equals c. And that allows us to come over here to a couple properties of logarithms. When the base of the log and the base of this portion is the same, what that's doing, if I were to translate this into exponents, I would go my base b from down here to my exponent x equals, well, g now, b to the x. And so that's why we can kind of cancel out those two b's, and we get x up here equals x over there. Then on the other side, when we have the base b and the base of our logarithm the same, we can also cancel out those, and we get x equals x for the exact same reasoning. Then in some of our properties for logarithms, we can multiply with our logarithms if our functions are one-to-one, that if they're invertible, and we're only allowed to do that if these guys are the same. Now, some of the properties that we have used in exponents, we're going to use that thought process to help us out with logarithms. So for instance, if I take x squared times x cubed, you would all tell me that that's the same thing as x to the fifth, because you took x to the 2 plus 3. And so in logarithms, the addition that we have up here is the same thing as the multiplication that we have over there. And we're going to use that for one of our properties of logarithms. I think it's on the next slide. And I'm going to refresh your memory about exponents, like let's say I have x to the fifth divided by x squared. You know that we would take x to the fifth minus x squared. Well, that's where the subtraction and the division rule comes into play. And there's one more about exponents and multiplication. And if you think back to what exponents mean, like if I have x to the third, that's literally x times x times x. And so that's going to help us with an exponent and multiplying in one of our logarithm rules. I think I have them on the next slide. So here we go. In logarithms, if the logarithm is multiplying, that is the same thing as addition. And that's what I was trying to show you with the exponents of 2 and 3. If there is division, we can pull apart our logarithm into subtraction. And if we have, it's really hard to tell with what I have written out here. I'm going to say logarithm of x cubed. That is the same thing as having 3 out in front of logarithm x. And that's what I meant by having an exponent be the same thing as multiplication. So let's practice using some of these properties of logarithms in a few more examples. So we are going to try to take, it's hard to tell what the bases are here and what's a power and what's not, especially in the last one down there. Let's see if we can work with these a little bit. My first one is log base 2 of 8 over x. And so the first thing I notice is that there's a division in this. And so I know that division is telling me to subtract. So I would have the log base 2 of 8 minus log base 2 of x. And then this log base 2 of 8, I think I need to take a closer look at that. I need to see if I can simplify to figure out 2 to what power, so I'm thinking 2 to what power equals 8, and 3, 2 to the third gives me 8. So 3 minus log base 2 of x is my final answer. So as we're doing these problems, we need to recognize like powers of 2, powers of 5, powers of, some of the common powers so that we can simplify our logarithms as fully as possible. The next one, we have log, and it says 0.1. Well, I happen to know that that's 1/10. And then I have 10x squared. So 10 and x squared are being multiplied. So I'm going to pull those apart. So I have log of 1/10 10 plus log of 1/10 x squared. And then I notice that there's still a squared in here, so I need to take care of my squared term by bringing that out in front as a power. 2 log 1/10 x. Okay, so I've simplified that. And if I look at my first logarithm, I have 1/10 and 10. So if I think 1/10 to what power gives us 10, I think -1 does that. I think that'll flip my 1/10 and give me 10. So I'm going to put -1 plus what I had before. And so this turns out to be my answer. And now I'm having trouble reading my two problems down there. I think I have log, yeah, I can't tell what I have where. Oh, well, let me go with the ln, because I don't know what the next two problems are saying. So I definitely have ln, and in parentheses I have 3 over e, and I don't know if yours is different than mine, ex and a squared all on the outside. That look like what yours looked like? If it doesn't, that's the problem I'll work on. We'll see what happens. So there's a couple things I need to know. I need to know what is the base of ln, and how does that 2 impact everything? Well, the base of ln, it is a shortcut for saying that we have the natural log. And I swear that the French did this, I'm not kidding, because this is like the logarithm natural or natural, or, maybe you speak French better than I do. But the base, when we see ln, is base e. And that's going to help me because I have an e wrapped up inside this expression. So when I pull this apart, technical term is expand. I know I have a 2 sitting out in front. It's probably going to be with some big brackets. I'm going to have the ln of 3 minus all the stuff in the denominator, ln of e plus ln of x. Now, I know the ln of 3 is some random number. I know the ln of x is some, something with a variable. But this ln of e, I know that I have base e for my natural logarithm. So I'm going to come over here and try to figure out what the ln of e is giving me, like what is it, what value does it have? So I'm converting from logarithms to exponents, and I'm thinking e to what power is e? Well, how do I get, 5 to what power equals 5? It's the same question that e to what power equals e. The only way that that happens is if my exponent is 1. So the ln of e is 1. Everything else is going to stay. And you could distribute the 2 all the way through. You could distribute the negative sign inside the parentheses, but that's approximately what your answer should look like. On my PowerPoint on the tablet here, it's such a mess, I can't tell what's being divided. Like, it looks like I have log with the cubed root of something, and then I have another logarithm with like 11 and x squared minus 4, and I can't tell if those are involved in the same problem or if they're two separate problems. So we're just going on. So on this page, we want to use all of our properties of logarithms, and instead of pulling our logarithms apart, we want to put them back together. This is called condensing. So we say condense. That might be your set of directions. Hopefully I spelled that correctly. So in our first problem here, I see that we have log base 3 on both of them. So I'm going to have log base 3, big set of parentheses, and with the subtraction sign I know we'll have division. I would have x minus 1 and x plus 1, and that's as far as I can take it. In my second problem, I see I have log, log, log. That's all common logs. It's logarithm base 10. And then I have x and the 2y. Well, this 2 needs to go up as my exponent. And then my subtraction sign is telling me I need to divide by z. Now in number 3, I have a logarithm base 2, and the 4 means it has to go up in front, up as my exponent, so I'd have x to the 4th, but this 3 here, I need to get that back into log base 2, so I'm going to come down here with a little bit of like scrap work. So like log base 2 has to equal 3. So I need to figure out what goes into this part of my logarithm. So 2 to the 3rd gives me, well, I can figure that out. 2 to the 3rd is 8. So I have log base 2 of x to the 4th plus log base 2 of 8, and that means with my plus sign there that I need to multiply, and I would get a final answer, log base 2 of 8x to the 4th. And let's see what we can do over here with number 4. I've got the negative ln of x. Well, with a negative here, that needs to go up into my exponent. And I'm going to take that off out in front, because that's not supposed to be left in front of my ln. If I have an exponent of -1, that's like doing 1 over x. So I have the ln of 1 over x. Then I also have ln base e equals 1/2. So e to the 1/2, I have to figure out what goes in there. Well, e to the 1/2 equals, the only thing that equals is e to the 1/2, so I would say e to the 1/2. So I'm subtracting. And since both of those have ln's out in front with a subtraction sign, I can combine them together with ln, and there's 1 over x, and the minus sign is telling me that my e to the 1/2 is going into the denominator, or like that, because the exponent of 1/2 is the same thing as square root. Now, in our calculators, the common log, base 10, is what's programmed into our calculator, but not all of the logarithms we want to evaluate have base 10. So we can do a change of base using base 10 if we use this change of base formula. Some of your newer graphing calculators have this already written in, where you just type in where the little base goes and where x goes. Some of the older ones do not.